So yesterday I started talking about approximate integration, and so I'll just do a quick little recap of that. This would be for definite integrals where maybe the antiderivative is one that we cannot find. Maybe the trouble to find it would be take too much, and it might be better for our purposes to do an approximation of what the integral would be equal to. You might want to use this if you've collected data and you don't quite know what the integrand is. You just have the data, fits a certain model, and so get an approximation. So we could use 5 different things. Left hand or left end rectangles, right hand rectangles, midpoint rectangles, which I didn't do yet. We'll do that today. We could use some trapezoids. We could use parabolas. If you use trapezoids, it's a trapezoidal rule. If you use parabolas, it is a Simpson's rule. So one that I'd like to introduce this topic with is this problem right here. Now, this is a problem that you can do the integral of. For the definite integral, we got from 0 to 3. We actually calculated this yesterday, and it's 18. So I went with one that you know how to do, so then I can talk about certain things and why they're happening on this problem. So yesterday we did the left-hand rectangles, and I got this, and the approximation using the 6 left-hand rectangles was 15.875. And then we did, and now we also commented that this is what? An underestimate. And it's not that left hand are always an underestimate, but on this problem it was. And then we did the right hand rectangle, 6 of them, and I had gotten 20.375. So the right hand rectangles were an overestimate. After that, well, I talked about averaging the left hand answer with the right hand answer. And if you do that, you're actually doing the trapezoidal rule. There's a formula for the trapezoidal rule, although here it is on my graph, whereas we drew in the trapezoids, and I made a note that these bases, if you turn it sideways, you have those parallel lines forming a trapezoid if you want the parallel lines going the other way. But these occur twice because this one is in trapezoid 1, and this one is also in trapezoid number 2. So mention that, and here it's the formula for the trapezoidal rule, along with a problem that we didn't get the decimal approximation. Your job is going to be to get the decimal approximation for these problems. And I'm going to flip the page there to see. Here, I just wrote this out, and that's where we stopped yesterday. I'm not going to get the decimal approximation right now. You can do that. You have to remember, when you do plug this into your calculator, do not round off until you have the final answer. If you start rounding off some of those intermediate answers, your round off error can be so big that you end up getting, it's just going to be, it could be way too off. So so don't round off till you get the final answer.